Hi, I'm Frank O'Brien, and welcome to our talk on 20 years on the International Space Station. Now again, before we start, I hope you, your family, and friends have all been safe and healthy during this last year. And again, that's the most important thing right now. Now, the International Space Station, or the ISS as we call it, has just celebrated the 20th year of continuous occupation, with crews regularly flying up for 6 months assignments. Its primary job is science, and a lot of it is done all around the clock. But it's also a home away from home to the crews who are assigned there. Now, just a few quick words about me. I've been one of the editors of the NASA website that extensively documents the Apollo moon landings. And about a decade ago, I was accepted as a NASA Solar System Ambassador. There are about 1,000 of us all across the U.S. who go into communities and share insights on the NASA mission. I've talked all over, at schools and libraries and museums and computer conferences. We're often the first opportunity for those in the community to interact with someone who has direct connections to NASA. This is a fantastic all-volunteer program. No tax dollars are spent on it, and of course, we never accept any kind of compensation. This is what the future was supposed to be like. As soon as the year 2001. Of course, we were going to be taking Pan Am shuttles into space, stay at a Hilton on board the space station, and then go off to land on the moon. I was an impressionable 12-year-old at the time, and of course, all of this was going to be just around the corner. But that's not quite the way it turned out. But space stations were on the way. The United States had Skylab, over here on the right, and which flew soon after the Apollo program to the moon. Skylab broke endurance records several times in the middle 1970s and gave us our very first extended time in space. We learned huge amounts about the effects that space had on the human body and how to live and work for extended periods in orbit. The Russians also had several much smaller space stations which led up to their gigantic Mir space station, shown here on the left. This was continuously occupied for 15 years until it was deorbited in 2001 to make room for the space station, the International Space Station. They smashed records for time in space, with one cosmonaut spending over 14 months continuously on board the Mir space station. Now, all of this brings us to the present day. The International Space Station, again, we just call it the ISS for short, is an incredible science and engineering achievement that has brought together the nations of the world. It's massive, weighs in at about 1 million pounds, and its 15 living modules have as much interior volume as a 5-bedroom mansion. Its crew of 7 rotates over time, with crew members staying on board for about 6-month assignments. Orbiting 250 miles above, it's also moving incredibly fast, going at about 17,500 miles an hour. That's about Mach 25 for those who are keeping score. Now, it's important to understand that this is truly an international space station. It's not owned by the United States, but rather to 5 different member organizations. the United States, Russia, Canada, the European Union, and Japan. Astronauts from 19 countries have visited, and about 250 individuals have traveled there. Now, about 150 of those went multiple times. There were 2 folks who have been up 5 times. Can you believe that? I guess they must have liked the view or something. There have been a number of tourists, or spaceflight participants as they like to be called, who have also traveled there. And yeah, there might still be possible openings if you want to take a trip there yourself, if you have about $60 million sitting around. Operations both on board and on the ground are coordinated by an international treaty, which has been hailed as one of the greatest examples of international cooperations. The agreements between the nations is unique. Different countries provide different modules that are used to construct the space station, or they fly resupply missions that provide food, water, spare parts, and experiments. What occurs then is a bit of a barter system. Based on the country's contribution to building or resupplying the ISS, determines how many of those countries' astronauts can serve on the station. Very little actual money changes hands. Again, it's best thought as a barter system. For example, Canada makes the robotics arms on the station, but Japan has built a gigantic laboratory and regularly launches resupply missions. As a result, Japan's larger contribution allows them to send many more astronauts than Canada has. It really is a good system. Now, the ISS was not cheap to build. So far, about $150 billion has been spent in total by all the member nations over 25 years. Construction started on the first modules in the 1990s, several of which were launched by the year 2000. Total time from start to finish for the construction of the International Space Station was about 12 years to complete. The ISS is an international laboratory, and the primary objective is to study the human body during long space flights. Biology in general is a focus of the research, but there's also material science and some very advanced physics. Studies about how the human body adapts to life without gravity is important. If we're going to be taking a trip to Mars, the mission is likely going to last about 3 years. What happens to the human body in that amount of time? We've gotten some answers that we're going to be talking about at the end. Other experiments are manufacturing materials which simply can't be made on the ground. These include ultra-pure crystals and unique proteins. We're also learning how to grow our own food, and lettuce is an occasional crop on the station. One topic that's always studied is psychology, rather than the traditional hard sciences. How do you create a crew from totally different cultures, languages, genders, and philosophies, and get them to work together as a cohesive crew during a long mission? These are important things, again, for our much longer missions to the planets. Now, just for perspective, when we say the International Space Station is big, we mean really, really big. It would barely fit in a football field. Now, let's put a few things in perspective here. I'm a Wisconsin guy. Oh, yeah, I know everyone has their own passions about their local teams or their favorite players and all the rest. Well, I was born and raised a few different times in Wisconsin, so my affinities tend to go toward the Packers. So, here's a view of the International Space Station at the same scale as Lambeau Field in Green Bay. You can see it's simply massive. Of course, there are no rockets that could lift such a large structure in space at once, so it had to be assembled over 42 different launches. Newer modules are still scheduled to be added during the spring or maybe the late summer, so the ISS is continuously being upgraded and added to. Now, this picture makes you wonder. It's so big, can you possibly see the space station from the ground? And yeah, you most certainly can. And it's easy to see when it passes overhead. It's much brighter than any star and moves across the sky a little bit faster than an airliner. Of course, you can tell it's not an airplane since it doesn't have flashing lights on it. One place to go to find out if there's going to be a passage of the space station over where you live is to go to spotthestation.nasa.gov. Now again, this is the wonderful completed version of the ISS, but it didn't always look like this. Formal assembly of the ISS began when the Russians launched their Zarya module, which is over here on the left, in November of 1998. In an odyssey of diplomacy and contracting, Zarya is a Russian spacecraft originally designed to be used on Mir that the United States ended up buying, and now we own it. Apparently, this was cheaper than the American-based options. A few weeks after Zarya entered orbit, Space Shuttle Endeavour brought the Unity module over here on the right and docked the two vehicles together. Although the two modules mated together didn't have a life support system to host astronauts, it was a key milestone in the 12-year assembly of the ISS. Missions to continue the assembly went on for several more years, and with the addition of the Russian service module called Zvezda, crews could now start to be accommodated. The United States began assembling that truss structure you see going across, which carried essential solar panels and radiators, and is really the backbone of the entire space station. The Destiny module, which you can't see because it's on the other side, is the main U.S. research laboratory, and that was added early on. With the addition of an airlock and the Harmony module, which is used for the crew quarters, the core of the ISS was completed. Now, to be sure, many more modules were still needed to be added, especially the laboratories that were being built by the Europeans and the Japanese. However, additionally, other modules have been added over the years to support various science experiments. On to the science. One of the most difficult tasks in pharmaceutics is the preparation of ultra-pure crystals of proteins. Now, such crystals are necessary to understand the structure of the protein, and the structure of a protein drives how that particular protein functions. Gravity makes this incredibly difficult on Earth because the solutions used to prepare those crystals tend to stratify, and temperature differences which result prevent the crystallization from occurring in a controlled manner. This pure crystals that have been grown have already had significant clinical results. For example, the structure of the protein involved in the most common form of muscular dystrophy was synthesized in space, and from the results of that work, a new drug has been created by researchers. That drug is now in phase 3 studies and showing some rather impressive results. When doing cancer research, researchers try to create cell cultures that hopefully mimic the functions of the human body. From these cell cultures, they can test various chemotherapy and anti-cancer drugs against the cancerous cells. A large part of the research in solid cancer tumors is to find a way of disrupting the blood supply to the tumor, making it starve and die. Unfortunately, the cells that compose these blood vessels, the target of the therapy, grow very poorly on the ground. In space, these endothelial cells, as they're called, survive much, much longer, making it easier to assess how effective a novel anti-cancer agent is. As importantly, demonstrating that these types of cells can be easily grown on the station opens up entirely new capabilities in cancer and cardiac research. Even though the ISS is reasonably isolated from Earth, microbes do find their way aboard and begin to flourish. Walls of mold have been found behind panels, and the question becomes, is this harmful? Normally, a sample is sent back to Earth, but on a long mission to Mars, say, that just simply can't be done. Researchers have created an amazing device, the little gray box on the bottom right, that can perform DNA sequencing in just a few minutes. Now, only a few years ago, such a capability would have required an entire research laboratory to perform the sequencing, and obtaining the results would normally take hours, if not days. With so many medical experiments running on board this ISS, DNA sequencing is likely going to become a larger and larger part of that entire research process. Technology has now reached a point where very small satellites, maybe about the size of a loaf of bread, or some are even smaller, and the technology allows these satellites to have amazing capabilities. These small satellites, usually called a CubeSat, are incredibly inexpensive by aerospace standards, and they are often built by university groups and maybe even some high school departments. Some of the capabilities are truly impressive. Imaging systems that would have dazzled those in charge of the early spy satellites are completely commonplace now, and as are small but very sophisticated radars for doing ground imaging and rainfall observation. Because of their small size and weight, they're also not very expensive to launch. No longer do we need to spend $100 million to put a satellite up anymore. Every resupply mission to the ISS brings up a dispenser full of CubeSats, which are released according to the needs of its users. Satellite tracking, essential for communicating with the satellite and receiving the data that it's generated, has also been transformed. Believe it or not, both Amazon and Microsoft now offer satellite tracking services as part of their portfolio. The world around us seems real enough, as much as you can call it real. Matter, whether solid, liquid, or gas, fills our existence so well that it's impossible to imagine anything else being where the table or the laptop is. Yet, we also know that only 5% of the universe is that kind of ordinary matter that we can sense. Two other things take up the rest. About 69% of the universe is a mysterious entity that we just simply call dark energy. Unfortunately, we just don't have any solid ideas on what the heck it really is, but we do see its influence on the universe. Something called dark matter takes up the remaining 26% of the universe. Like dark energy, we can't see dark matter directly, but we can certainly observe the effects it has on the ordinary matter of the universe. There's a number of theories of what dark matter actually is, and these ideas have progressed to the point where we're now being able to build instruments to detect dark matter. The Alpha Magnetic Spectrometer is a joint project between the United States and Europe, and an early version of the AMS flew on the space shuttle in 1998. It's designed to study very high-energy cosmic rays and other particles in space. From this information, researchers hope that they're going to be getting an understanding about the nature and properties of this dark matter. Now, if you think that dark matter and dark energy are weird, you're just getting started. We're just getting started in modern physics. Many years ago, a bizarre, new fifth state of matter. Remember, the others are solid, liquid, gas, and plasmas. This new fifth state of matter was discovered, and it's called a Bose-Einstein Condensate. Yes, that's Albert Einstein. This is where matter is cooled down so much it stops behaving like ordinary matter and enters the quantum world. Now, I have an apology. If you want me to explain a lot of that further, I have to admit I simply don't pretend to understand quantum mechanics at all. However, an instrument designed to create Bose-Einstein condensates is on the International Space Station, and the data is exciting scientists around the world. Now, the name of the instrument is called the Cold Atom Lab, and that's probably one of the greatest understatements in science. Again, the idea of a Bose-Einstein condensate is that you need to start with an impossibly cold temperature. In space, the lack of gravity allows a particular cooling technique to work so well, the atoms are cooled to only a fraction of a billionth of a degree above absolute zero. We can't reproduce this on Earth. Now, because of the lack of gravity, the atoms can be observed for far longer times, and this allows us to make more detailed studies onto its characteristics. For long missions into space, fresh food is really a luxury. Yes, the meals that the astronauts have are healthy and nutritious, but let's be honest, they are pretty boring. Imagine having to spend 3 years on a trip to Mars, eating only the equivalent of military field rations. But right now, that's the only option. And it does get a little bit tough on morale. Food scientists have spent a huge amount of effort trying to make the meals more appetizing. But honestly, they've only had limited success. Clearly, the solution is to grow fresh food on board. But this isn't as simple as it sounds. Simply having a pot of dirt with a few buried seeds in it isn't going to work, since the soil will start floating around the station and getting into everyone's eyes and the equipment. We need to find a way to secure that dirt, and also a means to automatically irrigate the crop. Now, since you don't want to wait an entire summer to harvest your crop, questions come up like, is it possible to speed things up by keeping the lights on all the time? These are tough questions to answer. Right now, we've learned the optimal watering schedules and have identified plants that do well in 24-hour-a-day illumination. Now, not all plants do well 24 hours of lighting. Tomatoes and poinsettias are the classic examples because they need periods of darkness in order to grow properly. The growing chamber is here off onto the left, and its red light illuminates an otherwise dark laboratory. Why red light? Well, plants are green because they reflect the green light away from them. They don't use green light and prefer a combination of red with a little bit of blue light for growing. To date, crews have grown red romaine lettuce, radishes, Chinese cabbage, and even a flower pot of zinnias. Now, as you can see, we're not growing huge amounts of crops. After over a month of waiting, this crop of red romaine lettuce wasn't a lot, but at least it was a treat. Now, for a crew of 6, everyone only got a few leaves to taste, because the rest of the crop had to be packaged up and returned to Earth for detailed analysis. Given that crops take a long time to grow and require a lot of room for even small amounts of food, space crops probably will be limited to only morale-boosting treats rather than a primary source of nutrition. Hazards to your health. Okay, maybe that warning is just a bit severe. For short trips into space, up for a month or so, almost anyone who is reasonably healthy will do just fine and really won't have any side effects from the experience. But for long duration missions, such as those for the 6 months or so that the crews are regularly flying with, the situation changes quite a bit. Over time, there are significant changes to the human body, and most worrisome is that your bones lose their density and their mass. This is because there's no gravity, and bones don't need to be as strong, and just simply because they're trying to adapt to their environment. We find that the amount of bone loss in only 1 month in space is about the same as a year in a postmenopausal woman. On a 3-year trip to Mars, yeah, it's possible that a healthy 40-year-old astronaut will return to Earth with the skeleton of an 85-year-old woman. In essence, we need to find a cure for osteoporosis before we go on that long journey. Of course, NASA is very focused on solving this problem and is experimenting with several different therapies. One promising approach is using one of the popular medicines that are already being prescribed for osteoporosis, such as Fosamax and Boniva. There are other issues that result when putting humans in an environment that they really never evolved from. Your cardiac function is reduced because you're just simply not exercising as much. The immune system becomes less responsive, and the list goes on. Surprisingly, radiation isn't so much of a problem when you're in Earth orbit. A trip to the Moon and Mars, yes, it's certainly more problematic, but it appears right now to be manageable. But still, the big worry is the loss of bone mass. And there is one therapy, if you want to call it that, that does appear to help. Exercise. Lots of it. 2 hours a day, every day, no exceptions. But how do you exercise like you do in a gym when there's no gravity? As you might expect, NASA has this figured out.
Hello everyone, I'm NASA astronaut Jessica Meir, currently living on board the International Space Station. We thought we would share some of our tips on how to live successfully and happily while in isolation. Studies have shown that exercise is vital not only to your physical health, but also to your mental well-being. You may need to get a little bit creative to get that heart rate elevated while at home without heading to the gym, but we're confident you can come up with something. Here's how we get the job done on the International Space Station. Just like exercise being so vital to your health on the Earth, it's even more important to us up here. So this is the ARED, the Advanced Resistant Exercise Device, and it is basically our one-stop weightlifting machine. The ARED uses 2 large vacuum tubes to generate the resistance for our weightlifting. In microgravity, we would have very significant losses in bone density and also muscle atrophy. But by exercising, we can counteract and prevent that.
This next exercise is cardiovascular exercises, T2, treadmill 2. Bungees and my harness are holding me against the treadmill.
It's pretty fun to run on T2, get a little bit of an extra spring in your step. Another type of cardiovascular exercise that we have on the International Space Station is our stationary bicycle. It's called CBIS, and one of the interesting things we always like to point out to people on the ground, it's a bicycle, but we don't have a seat and we don't have handlebars, since we don't need that in microgravity.
And this gives us probably our most cardiovascularly intense workout. I get a much greater heart rate doing this than I do running on the treadmill.
One odd thing that does happen is that fluid tends to build up in your head, giving everyone the sensation that they're in the middle of a mild cold. And this also causes a strange effect that you start losing your sense of smell. This is because that when your body is standing, you want to be sure that all the fluids that you want to have put up into your head don't pool down by your feet. Otherwise, you'd faint. This is such a primal part of how the human body works. The process doesn't stop in space. One effect of this is that it places additional pressure on the eyeball, and it can permanently change your vision. When this was noticed many years ago, most folks assumed because the crews were getting to the age when everyone needs reading glasses anyway. So, pretty much was thought of just another part of getting old, and nothing related to spaceflight. We now know much, much better, and NASA is looking for ways to prevent it. Even though this is not a science experiment, one thing that is benefiting our ability to work in space is that we're developing the skills needed to repair a broken spacecraft, often with only things that are found on board the station. Early in the assembly sequence, one of the solar panels ripped when it was being unrolled. And you can see that rip down the center right part of the picture. Without this solar panel operating, the ISS simply wouldn't have enough power to function. So a plan was quickly put in place, and using spare wires and tape, the astronauts figured out a way to stitch the panel back together. While this achievement was amazing enough, the real danger was that the astronaut who was doing the repair, Scott Parazynski, had to improvise by using an inspection boom that had been attached to the robotic arm of the shuttle. There was no other way to get close to that solar panel. Even with that extension, it was a difficult reach, and there was serious worry about getting a shock from the solar panels. Another impressive repair on board the station was to replace the cooling system on the alpha magnetic spectrometer that we talked about earlier. This instrument is being used again to look for dark matter, and the results were so important that they decided a repair to its cooling system was necessary. Now, unlike many of the systems on board the station, the spectrometer simply wasn't designed at all for in-flight repairs. So, such an instrument was such a high priority that they spent several years trying to devise a way to completely replace its cooling system. Over 4 long spacewalks, crew members disassembled the spectrometer, installed a brand new cooling system, and returned the detector back to operation where it's working today. Exploration on the ISS isn't limited to only low Earth orbit. We're also making plans to go back to the moon and eventually back to Mars. During the Apollo moonwalks, it wasn't uncommon for the astronauts to slip and fall and get completely covered with dust from the surface. For years, NASA has been trying to improve the spacesuits used on the Apollo moon landings. The original designs were great, no question on that, but it came with serious limitations. We learned quickly that the lunar soil caused serious problems in the original suits, getting into connectors and zippers and everything else. After 3 days on the moon, the suits were very nearly at the end of their useful life. This is certainly not acceptable for a 2-week mission to the moon, much less than a 3-year expedition to Mars. So, there have been countless iterations of spacesuit designs, each trying to address the impact that the local environment was going to have on them. Science and engineering, done in a methodical, controlled test, are the key to figuring out new ways of designing the suits. Most importantly, if there are problems, and these are always going to happen, a safe haven or a quick return to Earth is an essential option. After all, the surface of the moon, or especially Mars, is the worst place to be when you find out that an idea you thought was pretty good really wasn't. Right now, a new generation of spacesuit for Project Artemis, the return to the moon, is undergoing testing in Houston. And you see, it's being done in a huge underwater tank. Testing on the ISS will validate the suit for use in space, ensuring that it's ready for when the next small step will be made on the moon. We now get into a bit of the creature comforts and the living on the space station aspect. A number of years ago, an Italian astronaut mentioned that he missed proper coffee, meaning espresso, because all that was available on the station was the same kind of instant coffee that you would get at the grocery store. Well, the Italian company Lavazza, who practically invented espresso, rose to the challenge. In a little over a year, they had built an espresso maker that would work on the ISS. Here's Samantha Cristoforetti, an Italian Air Force fighter pilot, making the first batch of espresso. The expression on her face is all you need to know about how big of a moment this was. And oh, by the way, if you ever make your plans to go up to the space station, please be sure to plan it around when the Italians are there. They always are bringing the best food. Oh, one thing that's always asked. Lavazza paid for this project out of their own pocket. Nobody's tax dollars were spent on it. Now, if you've ever stayed at a DoubleTree hotel, you know that the best part are the chocolate chip cookies that you get at the check-in desk. Well, just like the folks who made the ISS espresso maker, DoubleTree decided to have a special oven built and sent to the station. Aside from the obvious boost to morale that baking cookies in space brings, it's part of a serious effort to learn how to prepare meals in an oven in space. Right now, food, still in its packaging, is simply put into a warmer to heat it up. It works, yes, but the end result isn't really the most appetizing. We did learn that baking in space is a lot harder than you might think. Well, at least for making cookies. Baking takes several times longer than on Earth, and the ideal temperature turns out to be a little bit lower than what you would normally use on Earth. Well, this is why we do science. In addition to working on science, astronauts need to address the basic human needs like bathing on board the station. And the one thing that the ISS doesn't have is a shower. Now, on earlier space stations, both NASA and the Russians on their Mir space station thought a shower would be just exactly what they needed. And both of them failed miserably. Think of it. Water just floats around in blobs all around you, making washing and especially rinsing off almost impossible. So, the solution here is just to use a little bit of water soaked in a baby wipe. Yeah, there's a huge stash of Huggies wipes that they use in the morning and after exercising. And honestly, by all accounts, it does work pretty well. But this leads us to one of the great questions. How do you wash your hair in space? Karen Nyberg, flight engineer on the ISS, explains how.
Hi there. I've had a lot of people ask me how I wash my hair in space, and I thought I'd show you how I do it. Let's see. To get started, these are the things I need. A bag of warm water, a little no-rinse shampoo, towel, and my comb. What I like to do is start by just putting some hot water, squirting it onto my scalp. And I have a mirror here so I can kind of watch what I'm doing. Sometimes the water gets away from you and you try and catch as much as you can. Then I just work the water up through to the ends of my hair. And I take my no-rinse shampoo and squirt it also on the scalp, just a little bit, and rub it in. Again, kind of working it out to the ends. And sometimes I'll actually take my comb to help work it all the way to the ends. And I like to take my towel while I have the shampoo in there and just kind of work it. Because without standing under running water, you kind of need to use the towel a little bit to help get some of the dirt out. I like to follow that by a little more water. It's called no-rinse shampoo, but I think it's best if you use a little water with it. It actually feels kind of squeaky clean right now. Now I'll take the dry part of my towel. We use towels for quite a while here, since we have limited supplies. We use them wisely. There, I think that's pretty good. And now as my hair dries, as the water evaporates from my hair, it will become humidity in the air, and then our air conditioning system will collect that into condensate, and it won't be long, and our water processing system will turn that into drinking water. At the end, I just do one final comb through to make sure there are no snarls and snags, and while it dries, I like to let it stay free. I don't put it back in a ponytail while it's drying. And that is how I wash my hair in space on the International Space Station.
We've mentioned a few times about the supply ships that bring food and supplies and fuel to the ISS. This is one of them, the Russian ship they call Progress. And it's a type that's been servicing the various space station Russia has had for over 40 years. It's a workhorse and very, very reliable. Several countries do these kind of supply runs also, each with their own spacecraft. And the United States actually operates 2 different versions. Crews don't fly on these supply ships, and even though that they're monitored from the ground, most of their missions are entirely automated. Supplies are launched about every 6 to 8 weeks, and usually carry 2 to 4 tons of supplies. And yeah, you thought your car was pretty full after a weekly shopping trip. With so much stuff, it does take days to unpack and see that everything is properly stored on board. Once the cargo ship has been emptied out, it's filled with all the trash that's been generated on the station. Yeah, even on the ISS, somebody has to take out the garbage. Everything from dirty laundry, empty food packaging, and broken equipment are placed on board. Once it's full, the cargo ship leaves the station, fires its engines, and burns up in the atmosphere over the South Pacific Ocean. So, that's our talk about science and life on the International Space Station. It's a wonderful adventure that bridges science, engineering, and cultures. What we learn from this experience will not only help our own exploration of space and the solar system, but it also improves the lives of people here on Earth. Thanks again for watching this. I hope you appreciate all the science that we've done on the International Space Station. Next month, we're going to be talking about studying the nearest star to us, the Sun. Like so many of us, it's a bit middle-aged, but it still has amazing stories about its life and evolution. We'll be seeing you there.